Now let's talk about scientific notation. A positive number is written in scientific notation if it is written as a product of a number A, where 1 is less or equal to x is less than 10, and an integer power r of 10. So what that means is we have some numerical base and it's multiplied by 10 to a power. That base A has to be a number between 1 and 10, but it cannot be equal to 10. To write a number in scientific notation, we move the decimal point in the original number until that new number has a value between 1 and 10. It can include 1, but it does not include 10. We're going to count the number of decimal places the decimal point was moved. If the original number is 10 or greater, then that's a positive count. If the original number is less than 1, then the count is negative. So we're going to go through some examples to show you how all this works, because I know it can be a little overwhelming just to read all of these directions. Finally, we're going to write the product of the new number that we created in step 2 by 10 raised to some power. So let's try a few examples. So we're going to convert between scientific notation and standard notation. 730,000 is a standard way to write a number. Obviously, that number is not between 1 and 10. So if we were to think about where should a decimal be placed to make that a number between 1 and 10, we would be placing that decimal in between the 7 and the 3. So the first step is to decide where to place the decimal. 7.3. 7.3 is a number between 1 and 10. The next step is to multiply by 10 raised to some power that would get us back to the original number. In other words, we're really giving directions as to where to move this decimal. Move it to the right or move it to the left to get it looking like the original number. So this decimal would have to move to the right how many places in order to get back to 730,000? Well, that would be 1, 2, 3, 4, 5 jumps. So the exponent must be positive 5. So if we take this decimal and move it to the right 5 places, we will get back to the original standard notation. Now our next number is a number that's much smaller than 1. All right, is a decimal number. So right here in between the 1 and the 0 is where the decimal should be placed to make that a number between 1 and 10. 1.04. That is a number between 1 and 10. That will be multiplied by 10 raised to some power. So remember, you're trying to figure out which direction should this decimal be moved in order to make the number look like the original number. So this time we'd have to move it to the left. So we'll count 1, 2, 3, 4, 5, 6 places to the left means a negative 6. So 1.04 times 10 to the power of negative 6 is the same value as 0.0000104. We just have two different ways to write that number. Now notice here that we have a number that's not quite in scientific notation. 25.3 times 10 to the 7. So at first glance it looks like scientific notation, but look, 25 is not a number between 1 and 10. The decimal should actually be placed between the 2 and 5. So it should be 2.53 times 10 to some power. Since I moved this decimal one place to the left, I shrunk the number. So to compensate for that, I must increase the exponent by 1. So 10 to the 7 plus 1 makes 8. So the actual equivalent number in scientific notation would be 2.53 times 10 to the 8. So the general rule is, if one term is being made smaller, the other term needs to be larger to compensate or balance the number. So here we're going to start with a number in scientific notation and convert it back to its standard notation. 1.53 times 10 to the fourth power. Since the exponent is positive, that means we're moving the decimal to the right. So we're moving this decimal place to the right 4 places. Well, 2 of those places are already taken up with numbers, so it just means that we're placing 2 more zeros at the end of the number. 15,300 is the final answer. With 9.3 times 10 to the negative 7, since this exponent is negative, that means we move the decimal to the left 7 places. One of those places is already taken up with a number, so we just need 6 zeros in front of the 9. And there is our equivalent standard form. In the last example, 2.04 times 10 to the negative 3, again we have a negative exponent, so the decimal needs to move to the left 3 places. We have 1 place already taken up with a digit, so we just need 2 zeros. And here is the equivalent standard form. So I hope you found this lesson helpful with scientific notation.